I made the mistake for the first time for the semester with not finishing all of section 3.3, so I have one more problem that I will just put on here and tag on to 3.4. Example number 17 is actually pretty simple when it's all said and done. We have cotangent cubed of x equals the cotangent of x times the quantity cosecant squared of x minus 1. Now this is the more complex side, so I look at, okay, I've got cotangent of x, all I need this to be is to be cotangent squared, and that doesn't take too much. I mean, that is the Pythagorean identity. And so we get cotangent of x times cotangent squared of x equals the cotangent cubed of x. And so we have solved exactly as we needed. So that is sufficient for the last problem of section 3.3. Now, section 3.4, we get into finding exact values of some equations that are dealing with the sum and difference identities. And so, example number 1. We want to find what is the sine of negative 11 pi over 12. Now, the first thing we have to do is to come up with some combination, adding or subtracting, of angles that we know. And there are many, but the one I'm going to choose here is I'm going to take pi over 4 and then subtract out 7 pi over 6. And if you look, pi over 4 minus 7 pi over 6 will equal negative 11 pi over 12. And so then I can use the difference identity here. And so this would be the sine of pi over 4 times the cosine of 7 pi over 6 minus the cosine of pi over 4 times the sine of 7 pi over 6. And so sine of pi over 4 is root 2 over 2. The cosine of 7 pi over 6 is a negative root 3 over 2. And I'm not going to spend time figuring out how to get those. We should have the concept of that by this time. The cosine of pi over 4 is root 2 over 2, and the sine of 7 pi over 6 is a negative 1/2. And then it's just a matter of multiplying these together. We get negative root 6 over 2 plus, when you take the negative times the negative, root 2 over 4. This would be over 4, sorry. And so putting this all into one complex fraction, we get negative root 6 plus root 2 all over 4. And this could be written as root 2 minus root 6 all over 4. Example number 2. The sine of 255 degrees. Well, once again, we have to come up with two numbers that either add or subtract to that. And there are many, but I chose 45 degrees and 210 degrees because I can find the 45 degrees and 210 degrees. Those make very nice reference angles. And so this becomes the sine of 45 degrees cosine of 210 degrees plus the sine of 210 degrees cosine of 45 degrees. And once again, it's just a matter of plugging in the values. Sine of 45 degrees is root 2 over 2. The cosine of 210 degrees is negative root 3 over 2. The sine of 210 degrees is negative 1/2. And the cosine of 45 degrees is root 2 over 2. Then it's just arithmetic from this point forward. Negative root 6 over 4 minus root 2 over 4, and combining into a complex fraction, negative root 6 minus root 2. Number 3, 4, 5, and 6 actually work in reverse. Basically, we have the sine of 25 degrees, cosine of 35 degrees, plus cosine of 25 degrees, sine of 35 degrees. Well, I look at this, and this appears to be the right-hand side of sine with the angles being added, or the sum identity. So that's going to be the sine of the two angles added together, 25 plus 35 degrees. Well, that would be the sine of 60 degrees, which simply is equal to the square root of 3 over 2. Example 4 is very similar. Cosine of 50 degrees, cosine of 10 degrees, minus the sine of 50 degrees, sine of 10 degrees. Well, I look at this, and this is certainly a cosine, and it happens to be the cosine of the sum identity. In other words, we're adding, so it's 50 plus 10 degrees, or we're going to find the cosine of 60 degrees, which is equal to 1/2. Example number 5 appears to be quite a mess. The tangent of 5 degrees plus the tangent of 25 degrees all over 1 minus the tangent of 5 degrees, tangent of 25 degrees. But upon further inspection, this is just the sum identity for tangent. Tangent doesn't come out quite so nice. And so this is going to become the tangent of 5 degrees plus 25 degrees, which equals the tangent of 30 degrees, which is equal to the square root of 3 over 3. Number 6 is very similar. 1 minus the tangent of 80 degrees, tangent of 70 degrees, over the tangent of 80 degrees plus the tangent of 70 degrees. Now this looks very similar to the sum identity of tangent. The only problem is it's the exact reciprocal of what we want. So actually what this is going to become is the reciprocal of whatever we're dealing with. So the reciprocal of tangent is cotangent, and we are going to add these up, 80 degrees plus 70 degrees. Well, that becomes the cotangent of 150 degrees, and with a little bit of manipulation and understanding how cotangent's related to tangent and reference angles, so on and so forth, we get negative square root of 3. The next group of problems asks us to find the exact value under the given condition. And so we start out with the sine of alpha is 24/25. And we know that alpha is somewhere in that range. In other words, it's in the first quadrant. Likewise, the cosine of beta is 5/13. And we know that beta falls in the first quadrant as well. And so since both of them are in the first quadrant, we're dealing with positives, so we don't have to worry about that. But nowhere in our table will we see 24/25 or 5/13. So what I need to do is I need to draw two different triangles. One's going to have the angle alpha, and the other one's going to have the angle beta. Now with alpha, I know sine is 24/25, so that would be 24 here, 25 here, and realizing that this is this particular it's not 5, it is 7. So if I would learn my Pythagorean triples a little bit better, wouldn't have been such a problem. And then for beta, cosine of beta would be 513, and so this would be the value of 12, which is part of the Pythagorean triple. And so what we want to do is we want to find what is cosine of alpha plus beta. Well, cosine of alpha plus beta, what we need to do is we need to go ahead and just write out the equation. So that is cosine alpha cosine beta minus sine alpha sine beta. And then it's just a matter of plugging in the values here to figure out, you know, what's what. Okay, cosine of alpha. We know everything's in quadrant 1, so everything's good. And if we need to, we can just actually show that for each of these triangles so that we don't forget. Okay, cosine of alpha. I look over here, cosine of alpha would be 7/25. Cosine of beta. Well, we can cheat. Cosine of beta is 5/13, but we should also be able to find that from our triangle. Minus the sine of alpha. Sine of alpha is 24/25. And the sine of beta would be 12/13. Just doing some arithmetic from this point forward, 25 times 13 is 325. And 7 times 5 is 35. And 24 times 12 is 288. So we get 35 325ths minus 288 325ths will equal a negative 253 325ths. And that is the exact answer.